Hello, my name's Mark. I'm a Systems Engineer with Riverbed and I work with the Stingray business unit. Today I'm going to be showing you a demonstration of cloud bursting, making use of Stingray's features such as auto-scaling, global load balancing and event mapping. But before we get into the demonstration itself, first of all I think we should spend a few moments talking about cloud bursting and what it actually is. So I went to Wikipedia and I typed in cloud bursting, hoping to get a good definition I could use here. Unfortunately, I got redirected to some information on a device called a cloudbuster. Now, this presentation is not going to be about the principles of orgon theory. So if you're here expecting to find out how to produce rain, then I'm afraid you're in the wrong place. I went to Google and did another search, and I got this definition from Search Cloud Computing. Cloud bursting is an application deployment model in which an application runs in a private cloud or data center and bursts into a public cloud when the demand for computing capacity spikes. So that's the type of cloud bursting we're going to be looking at today. So remember, these are not the clouds you're looking for. These are the clouds you're looking for. Any public cloud service, in fact any private cloud service, can be used for cloud bursting. All they need to have is an API which allows you to deploy machines into the cloud. So what actually is cloud bursting then? Well, cloud bursting, first of all, has nothing to do with orgon theory, not in this presentation anyway. So if you're here about hoping to see some of that, then I'm afraid you're in the wrong place. So cloud bursting is the ability to make use of cloud resources on demand, pay by the hour for the additional resources only when you actually use them. It allows you to dynamically scale out your service beyond the bounds and resource constraints of your data center, physical, virtual or cloud. It's a hybrid cloud infrastructure which allows you to take advantage of cloud scalability without sacrificing the benefits you get from your physical data center. So why would you use Stingray for making use of cloud bursting? Well, Stingray is the only pure application delivery controller that is entirely written in software, which means we're deployable anywhere, physical, virtual or cloud. That means you can use the same application delivery controller in every environment in which you deploy services. Stingray has the auto-scaling feature. That allows you to dynamically deploy servers and scale up and down the number of servers you need based on demand. We have global load balancing as well, which allows you to distribute traffic across multiple active data centers. And traffic intelligence. So we provide deep packet inspection, advanced monitoring, traffic script rules language to implement complex or simple business logic, and alert mapping. For cloud bursting, you need all of these things. So let's talk a little bit about the demo. In the demo, we're going to be using two data centers. One is in Rackspace and one is in Amazon. The Rackspace data center is going to behave as my normal DC. So this could be a physical data center, it could be a private cloud running VMware or some other hypervisor. It could even be using physical machines. But in Rackspace, we're going to allow some scaling. So in this case, it would need to be some kind of virtual environment. So we're going to make use of our autoscaler to scale up nodes in Rackspace up to a maximum of 2 web servers. Once we hit that maximum, that is when we will initiate cloud bursting. So in the demo, I'm using Amazon EC2 as my cloud bursting location. So Amazon Web Services is usually empty. Cloud bursting, when it happens, will deploy Stingray into EC2, and once that is up and running, it will then begin scaling out web services by deploying nodes in EC2 as well. So in order to get traffic from Rackspace to Amazon, this is where the GLB comes in. So the global load balancer will send all users to Rackspace Cloud while the Amazon instances are all offline. But once Amazon does have running instances, the GLB will detect this and start distributing users to both Rackspace and Amazon. In the demo, I'm using geographic-based load balancing to distribute users across the data centers. Okay, I think that's everything you need to know. Let's get on with the demo. So, the demo. Here we have a stingraydemo.com domain, which is hosted on a traffic manager, and supports cloud bursting and auto scaling. This is just a simple website which is running on that domain. The home page has some information about the traffic manager. We have some other tabs on here as well. So we have a shop, which is just a demo shop. It's actually Magento with the standard demo content on it. We've also got a news page, which we will be looking at quite a lot during the demo. And we also have this pause page, which we're going to be looking at too. The pause page is actually a CGI. And what it does is it pauses for a period of time before responding to the request. This makes Stingray believe that or see longer response times from the web servers. The reason that's important is auto-scaling is based on response times. So in order for us to artificially make Stingray believe the web servers are under load, we use this pause page to increase the response times to requests. I'm going to be kicking off a script soon, which is going to actually be running continual requests against this pause page, and that is what we will do to artificially simulate load against the system. While those requests are running, we will be looking at the news page. The news page has information about the current state of the cluster. So you see we've got this cloud map here. This shows us what currently is deployed. We have a single Stingray and a single web server running in Rackspace. Nothing at all is running in Amazon. So this is the unloaded state. Also on here we have this Twitter feed, which is monitoring Riverbed Stingray. Riverbed Stingray is actually the traffic manager. So whenever the Stingray traffic manager makes a change to auto-scaling or the cloud configuration, it will tweet about it, and hopefully within a few seconds they will appear up in this widget. Finally, at the bottom of this page we have news page request info. This section is only updated when I click the news button. This picture is updated every 5 seconds, and this feed is updated as and when tweets come into the system. Okay, but this information at the bottom tells us the current time, it tells us who served the request, and what pool they are in. So currently, all requests going to stingraydemo.com are being served by Rackspace, and that is because there is nothing deployed in Amazon. So before we go on, let's just confirm that with the traffic manager's configuration. So here we have my Rackspace traffic manager. As you can see, there is indeed only one traffic manager in Rackspace. And if we go and look at the Rackspace pool of servers, you'll see there is only one node, and it maps up to the one that served our page here. So how does it all work? Well, we have a GLB service, which is monitoring the availability of Amazon and Rackspace, and is using geographic load balancing to send users to one or the other location. When they get to that location, they're going to come into this web service. The web service then decides which pool it's going to send the user to, and it does that based on where they've come into. So if you come into the EU West location, which is Amazon, you'll be sent to the Amazon pool to be load balanced. If you come into the Rackspace location, you'll be sent to the Rackspace pool to be load balanced. Obviously, currently, Amazon is offline, so nobody is hitting EU West. Everybody is hitting Rackspace, which is that one server in that we just saw. I have a third service on here called TrafficScript DNS Server, and this is just a simple DNS server written in TrafficScript, which is actually responding to the GLB requests. Ordinarily, you wouldn't need this service. Okay, so now you've had a quick explanation of how it all fits together. Let's look at the actual system. So I have a connection to a server here, and I'm just going to run a dig on stingraydemo.com. As you can see, when I look up stingraydemo.com, I get an answer, and the answer is 50.56.216.7, which is the Rackspace IP address. It's not currently going to respond with the Amazon address to anyone, because as we know, it's offline. So I'm going to run the test now, and I'm going to do so by using a little script that I prepared earlier called ztest spoof stall. And what this does is it sends requests to Amazon and Rackspace, gets the IP address that is returned, and then makes a web request to that IP for the pause page. So when this is running, it is going to simulate load on the server, and because we're hitting the pause page, auto-scaling is going to kick in, and then cloud bursting, because we will believe the system is under increased load. So let's kick that off. So while that's running, you can see we run tests against Rackspace and AWS on each iteration, and we're continually being sent to 50, 56, 2167. But now that's running, the system should start to detect some load. As you can see, we have a growth condition here. Growth condition must persist for 10 more seconds before a pool can grow. So what is actually causing that? If we go and look at the pool configuration, you will see that. You will see what's going on. So pools, into the Rackspace pool, and the auto-scaling settings. So in here we have auto-scaling enabled. We have an image ID, flavor ID, and this is the name prefix, which is auto web server, and this should map to auto web server here. We currently have one, but I get a feeling we've kicked another one off by now, so let's have a look. Reload the server instances. Nope, not yet. Well, that will happen shortly, I'm sure. So if we look further down, you can see our minimum nodes and maximum nodes, which determine how we can scale the pool. And finally, at the bottom, we have the response time. So our response time is set to 1 second. If a response is received within a second, then it's considered conforming. If it's more than a second, it's considered non-conforming. The scale down level says when we will destroy a node. So if we are at 95% or higher conformance, we will try to scale down the pool. If we are at 40% or less conformance, we will attempt to scale up. So back here, nothing much happening. Oh, we've now started deploying another web server. So Auto Web Server 1 is now being deployed by the auto-scaling instance. Oh, and we do have some updates from Twitter now. So 45 seconds ago, Rackspace auto node creation complete, creation of new nodes are now complete. So this is the autoscaler, and there it is. So it's just been deployed, and it is now available in the pool. So if I reload this page, I'm on 10.161, reload again maybe, and I'm on 162. So you can see I'm being load balanced across 2 pools. If we go and look at the Rackspace config, you can see that there are indeed now 2 nodes in this pool. But we are still generating load. If we come back to this, you can see we're still being sent to 50, 56, 216.7, but we're now being load balanced across 2 nodes. What's happening now is Stingray is re-evaluating the situation. If we go into auto-scaling again, you'll see we have this other value in here called auto-scale refractory. This is the time Stingray will wait between making a change to the pool and making any other changes. So after 2 minutes time have passed from this node, the new node being deployed, we will recheck. If we are still below 40% conformance, then we will hit a scale up event. However, max nodes is set to 2, so we will not be allowed to scale within Rackspace. This presents a problem. What do we do there? Well, I can actually write a trigger for this event, for the max nodes event, and cause cloud bursting to come into effect. So let's go and have a look at that now. So under System, Alerting, I have an autoscale max event. And this autoscale max event is looking at Rackspace and is interested in a maximum size reached event. So when that event is triggered momentarily, it will talk to Amazon and start deploying a new node in Amazon. As you can see, there is only 1 node running here, but that's nothing to do with our demo. There you go, hit refresh, and we're currently pending on that. Back over here, and we can see Twitter has, or rather Stingray has tweeted that it's about to cloud burst, and it's launching a Stingray instance in Amazon EC2. That's another Rackspace message, because obviously it is still under load. So this machine is currently being deployed, and it is a Stingray instance. Once it's been built, it will attempt to join the cluster with the Stingray in Rackspace. Once it joins the cluster, it will then start auto-scaling in the cluster. So before that comes up, let's have a look at the map. So this map is showing us the current status of all requests coming into Stingray and where they're being sent to. I'm going to change this to web service so that we're only looking at the web service requests. So the requests are coming in. They're all being sent to Rackspace at the moment, which is in Dallas in the US. We have auto-scaled that pool, and we have 2 nodes. We are also in the process of cloud bursting. So there is currently a Stingray instance being built in Amazon. Once the instance is built, still pending at the moment, but once the instance is built, it will join our cluster. And you will see in Ireland another data center appear. Once that data center is up, it will then start to deploy nodes. We won't start sending traffic to Amazon until we have seen some successful requests go through to the back-end nodes. So what other alerts do we have then? While we're waiting for that to come up. So I have this autoscale max, which obviously does the cloud bursting. I also have an Amazon terminate event, which does a cloud terminate. So when Amazon will scale up, but when the load drops off, Amazon will at some point become idle. When that happens, the nodes will be destroyed. Unlike Rackspace, Amazon's minimum nodes for its autoscaler are 0. So it can actually scale down to having no nodes at all. When that happens, this Amazon terminate event is triggered, and we will terminate the traffic manager in Amazon. Alright, 359. Oh, it's running. So any minute now, that traffic manager is going to start talking to my cluster. If we go home, oh look, you can see. Now, the reason it's red is because a number of processes happening. We have to connect, we have to copy config over. Because it's on Amazon EC2, once we've connected and copied the config, it then will change its IP address, because we want this Amazon machine to use an elastic IP. But you can only have one IP assigned to an Amazon instance. So once it's been copied its configuration and tries to get its Amazon IP, it will then switch. So at the moment it's on 176. That should turn to a 42 address any second. Okay, so we've lost connection because it's changing IP. Once the IP comes back up, that should come up on, okay, connected. Let's copy this config, it's connected. It should switch to the elastic IP. Any second. Okay, timed out, that's good, because it's switching. Oh no, there you go, it did switch to 46. So it's now on 137, sorry, 163.24.2, which is our elastic IP. Cluster should sort itself out. Okay, so back over here, we now have this instance running. Rackspace has decided to scale down in the meantime. But that's now running. AWS is working again. If we follow the logs, what is happening now is that should have kicked off a provisioning action, and there you go. So the Amazon Stingray is now provisioning a web server. Once this web server is built, it can start accepting traffic. So you can see status map is updated. We've lost a node in Rackspace, but not too worried about that. We've got 2 Stingray instances, and we're waiting for the web server to come up now. It's running, and it's in there, so it's been added to the config. Twitter, it said, that's the Rackspace being destroyed. There's the Amazon node created. Amazon auto node status, yeah, that's all running, that's all happy. So at the event log now, any second, if we haven't missed it, we should see GLB kick in and start and tell us that we have got traffic. You can see the yellow dots appeared, but because we haven't noticed that the web servers are up and they haven't responded successfully yet, we're still sending everything over to Amazon. Oh, here we go. We've started sending requests to Amazon as well as Rackspace now. So on this map, you should start to see some yellow dots appear, and there we go. And because we're using geographic load balancing, you should see yellow dots appearing over Europe and the purple dots appearing over the US. This yellow dot here is actually the health monitor, and that is specifically requesting Amazon, which is why it's there. And there you go. That's geographic load balancing along with cloud bursting. all running happily. And in fact, if I reload this page, depending, okay, maybe I need to open, let's try and open another browser. Open a new browser, and as you can see, I've been load balanced to the Amazon version of the page. And there you go. That is cloud bursting.